Imagine for a moment that you've just heard the universe's oldest whisper, a murmur that traveled for 13.8 billion years across the cosmos to reach us. An echo so faint it's a trillion times quieter than the smallest sound we can hear, yet it carries the secrets of the universe's very birth. This is the cosmic microwave background radiation, and it's all around us right this very moment, passing through your body as you watch this video. If you were to grab an old television, one of those with an antenna, and tune it to an empty channel, about 1% of those dancing dots on the screen would be caused by this ancient radiation. That's right, you'd literally be seeing the baby universe. Today, we're going to embark on a fascinating journey to discover how we found this cosmic fossil, how it tells us the most epic story ever told, that of the cosmos's very birth, and what it reveals about the destiny of everything that exists. Welcome, cosmic explorers. I'm your guide on this adventure through the universe, and we're on an incredible journey towards our first 1,000 fellow explorers. Get ready, because you're about to discover how two scientists trying to improve telephone communications ended up stumbling upon the most important discovery in modern cosmology. Let's begin our exploration by understanding exactly what this mysterious cosmic microwave background radiation is. Imagine the entire universe as an immense fireplace that, billions of years ago, was incandescent with heat. In the beginning, about 380,000 years after the Big Bang, the cosmos was a hot, dense soup of particles, so hot that not even atoms could form. It was as if the entire universe were the inside of a gigantic star. At that time, the temperature was about 3,000 degrees Celsius, hot enough to instantly melt copper. Light couldn't travel freely because it was constantly absorbed and re-emitted by free particles. The universe was opaque, like trying to see through a dense fog. But then, something extraordinary happened. The universe cooled enough for the first atoms to form. Electrons finally managed to stick to atomic nuclei, a process scientists call recombination. When that happened, it was as if someone had turned on the light in the universe for the first time. Suddenly, light could travel freely. And this first light, this first cosmic flash, is exactly what we detect today as cosmic microwave background radiation. Think of it as the universe's first photo, taken when it was just 380,000 years old. But here's the truly fascinating part. This light traveled for 13.8 billion years to reach us, and throughout that entire time, the universe kept expanding. And you know what happens when space expands? It stretches light, as if you were stretching a spring. This light, which was originally orange-red, like that of a campfire, was stretched until it became microwave radiation. Invisible to our eyes, but detectable by special instruments. It's as if the universe were a balloon being inflated, and the light waves were drawings on the surface of that balloon. As the balloon grows, the drawings stretch and get bigger and bigger. Today, this ancient radiation is at a temperature of just 2.7 degrees above absolute zero, colder than dry ice. Now you must be wondering, how on earth did anyone manage to discover something so subtle? This is one of the most incredible stories in modern science, and it involves two scientists who weren't even looking for the beginning of the universe. It was 1965, and Arno Penzias and Robert Wilson were working at Bell Laboratories in New Jersey, trying to improve satellite communications. They had a very sensitive antenna, the size of a house, that picked up radio signals. But there was an annoying problem. No matter where they pointed the antenna, there was always a constant background noise. It was like trying to listen to music on the radio, but always having a persistent hiss. They thought of everything. Maybe it was interference from New York. Maybe it was the nuclear tests of the time. Or even, and this is true, pigeon poop that had accumulated on the antenna. They meticulously cleaned every inch of the equipment, removed the pigeons and their deposits, but the noise persisted. It was as if space itself was whispering to them. Meanwhile, just 60 kilometers away, at Princeton University, a group of scientists, led by Robert Dick, was looking for exactly this type of radiation. They had theoretically predicted that if the Big Bang truly happened, there should be residual radiation permeating the entire universe. When they learned of Penzias and Wilson's problem, they immediately realized that they had found the holy grail of cosmology. The discovery was so important that it earned Penzias and Wilson the Nobel Prize in Physics in 1978. They had literally discovered the echo of the Big Bang. It was like finding a dinosaur footprint, but this footprint was from the very birth of the universe. But the story doesn't stop there. Since then, increasingly sophisticated space missions have mapped this radiation with extraordinary precision. The COBE satellite in the 1990s, then WMAP, and most recently Planck, created maps of the baby universe with details that would make any detective envious. These maps revealed something surprising. The cosmic microwave background radiation isn't perfectly uniform. There are small temperature fluctuations, tiny variations of just a few parts per million. To understand how small that is, imagine you're measuring the temperature of an entire Olympic swimming pool, and you can detect differences smaller than 1/1000th of a degree. These small variations are the seeds that gave rise to everything we see today. Galaxies, stars, planets, and even us. They are like small ripples in a lake that, billions of years later, became tsunamis of matter and energy. Without these microscopic fluctuations, the universe would be perfectly smooth and empty. There would be no stars, planets, or life. The cosmic microwave background radiation tells us an incredible story about the universe's past. First, it confirms that the Big Bang really happened. It's no longer just an elegant theory, it's an observable fact. The universe had a hot and dense beginning, and this radiation is the physical proof that has survived to this day. Second, it tells us exactly what the universe's composition is. Through detailed analyses of this radiation, we've discovered that only 5% of the universe is made of ordinary matter, atoms like those that form our bodies, planets, and stars. The other 95% are composed of dark matter and dark energy, mysterious substances that we cannot see directly, but which completely dominate the cosmos. It's like discovering that the house you've always lived in is 95% invisible. The cosmic microwave background radiation also gave us the exact age of the universe, 13.8 billion years, with a precision of just 100 million years. This might seem imprecise, but imagine trying to guess someone's age and being off by only 2%. It would be like guessing that a 30-year-old person is between 29 and 31 years old. Even more fascinating, this radiation revealed to us that the universe underwent a period of cosmic inflation. Right after the Big Bang, in a fraction of a second shorter than the blink of an eye, the universe expanded faster than the speed of light, growing from a size smaller than a proton to the size of an orange. It seems impossible, but the marks of this violent expansion are imprinted in the cosmic microwave background radiation like a cosmic stamp. Do you know what's even more impressive? This radiation also tells us about the universe's future. By analyzing its composition and the physical laws it reveals, scientists can project the cosmic destiny. And the answer is both melancholic and poetic. The universe will continue to expand forever, becoming colder and darker. Trillions of years from now, when the last stars burn out and black holes evaporate, the cosmic microwave background radiation will still be there, but it will be so cold and diluted that it will practically no longer exist. It will be like the last whisper of a conversation that began almost 14 billion years ago. But before you get melancholic, remember that we still have trillions of years ahead of us, and the very existence of this radiation connects us deeply with the cosmos. Every photon of this radiation that passes through our body is a direct messenger from the primordial universe. It's like receiving love letters written by the cosmos itself billions of years ago. The cosmic microwave background radiation is also helping us make new discoveries. Recently, scientists used it to detect structures in the universe that we can't even see directly, such as gigantic filaments of dark matter. It's like using an old map to find buried treasures. The ancient radiation serves as a map of the young universe that guides us to discoveries in the current universe. Let's take a break to absorb the magnitude of what we've just explored together. We discovered that there's a cosmic whisper permeating all of space, carrying the story of the universe's birth. We learned how scientists trying to improve telephones ended up hearing the Big Bang's echo, and we saw how this discovery revealed to us the composition, age, and destiny of the entire cosmos. The cosmic microwave background radiation is more than a scientific discovery. It's a bridge between us and the primordial universe. It reminds us that we are literally made of stardust, and that our existence is intrinsically connected with the grandest cosmic story ever told. When we look at the night sky, we're not just seeing distant points of light, we're contemplating our own origin. This leads me to a profound reflection. If we can hear the whisper of the universe's birth, what other cosmic secrets are still waiting to be discovered? Perhaps somewhere in the depths of space, Other life forms are also detecting this same ancient radiation, asking the same questions as us about their origins and destiny. Cosmic explorers, let us know in the comments what fascinates you most about this direct connection we have with the primordial universe. Do you think we'll ever be able to detect even older signals, perhaps from the very moment of the Big Bang? I love reading your reflections and seeing how our community thinks about these cosmic mysteries. And since we're talking about fascinating discoveries, what universe mystery would you like me to explore in the next video? Supermassive black holes, the search for extraterrestrial life, the multiverses. Leave your suggestions in the comments. You are the ones who guide our exploration journey. We're on an incredible journey towards our first 1000 cosmic explorers. If this video expanded your horizons and sparked your curiosity about the universe's secrets, join our crew by clicking subscribe. Every new explorer who joins us brings us closer to our goal and strengthens our community passionate about cosmic mysteries. Like this video if it made you hear the universe in a completely new way, and share it with someone who also marvels at the cosmos's grandeur. In the next video, we'll dive even deeper into the mysteries you choose, because together, we're always expanding the frontiers of cosmic knowledge. Until our next adventure through the confines of the universe, keep looking at the stars and remembering that you carry within yourselves the same energy that gave rise to everything that exists. The universe isn't just something we study, we are the universe knowing itself.